Welcome to our channel. In this lesson, I want us to do a practical that involves titration. Titration is one of the analyses that is tested in KCSE paper 3. So here we have some students who will do or demonstrate for us a type of titration called acid-base titration, which is direct titration. So here you are provided with hydrochloric acid, that is solution N. That's now hydrochloric acid, which is labeled as solution N. That's very good. Then you are also provided with the solution L, that's now sodium hydroxide, solution L, which contains 20 grams per liter of sodium hydroxide. That's very good. We are also provided with an indicator. So the type of indicator that you are going to use here is a phenolphthalein indicator. Phenolphthalein indicator. So that's another phenolphthalein indicator. It is the one that's going to determine the end point of that reaction. That's very good. Now, other than that, we are also provided with the conical flask. We also have a conical flask that measures about 250 ml. About 250 ml. We also have a complete stand here. That's another stand. So that's another stand that's used to hold the burette. And then I have a burette there. Burette usually measures from 0 to 50. So that's another 0 calibration. It runs from 0 to 50. That's very good. And then you also have a pipette there. We also have a pipette. A pipette, the one that we are using now, is a 25 ml pipette. So 25 ml, that's not 25 cubic centimeter, it measures up to that mark. Usually a pipette is used to deliver a solution. That's very good. Now remember, the aim of the question is we are required to determine the concentration of solution N in moles per liter. That is a concentration of hydrochloric acid. Usually, when you are doing an acid-base titration, you are always given two solutions. That is one standard solution. Standard solution is a solution whose concentration is known. So in our case here, the standard solution is sodium hydroxide because we are given the concentration, which is 20 grams per liter. Which is 20 grams per liter. And then the analyte means the one that we are going to analyze, the one we are looking for its concentration, and that's now hydrochloric acid. That's now solution N. Now, the procedure. Number one, fill the burette. You fill the burette with solution N. So now we take solution N. Solution N, which is hydrochloric acid. We put it in the burette. That's very good. So we fill the burette with solution N. So the next procedure is we pipette solution L. Now we have pipetted the solution L, we put it in a conical flask. We run it into the conical flask. Good. Then from there, we add 3 drops of phenolphthalein indicator into the solution in the conical flask. So that's another color change. Remember, what we pipetted was sodium hydroxide, solution L. And we have added now phenolphthalein indicator. So the color change, learners, is pink. So always phenolphthalein indicator turns pink in basic solution, that's now sodium hydroxide. So this solution now we are going to titrate with solution N from the burette. So now the solution turns to colorless there. Initially it was pink. So now the solution turned colorless. Now I want us now to read now the titer volume there. So what is now the titer volume? It is at 12. So now the reading, if you check it well, first experiment now, the titer volume is 9.1 cubic centimeter. That's very good. That's now where the end point of the reaction is. Now you can do more of that. You can do more of that. You can repeat two more times so that you get the accurate result. But since we did it accurately, then we are able now to fill that table for titration, and there is a way to do it. So now I want us to fill that titration table. So as you can see, there is a burette reading there. We have the initial burette reading, and then finally you have volume of solution N used. Now the initial burette reading for the first experiment was 0.0. Remember now, when you are always filling the table, you must use 1 decimal place throughout. So the final burette reading was 0, so we are using 1 decimal place, which is now 0.0. Now after doing the titration, the final burette reading was 9.1. Now for you to get volume of solution N used, now you subtract final minus initial. That is now 9.1 minus 0.0, which is now 9.1. Now for the second experiment, for you to obtain, you refill the burette with solution N. So it becomes 0.0, 0.0. Now for the second experiment, it is final burette reading will always be plus or minus 0.1 of the first final burette reading. And our first final burette reading was 9.1. So if you want to get now the volume there, it will be 0.1 plus 0.1 or minus 0.1. 0.2. That's good. So the final burette reading for the second experiment will be 9.2. Now for the third burette reading, remember now these values, they should be within the range of plus minus 0.1. So the other one now will be, the initial burette reading will be 0.0 because you refill the burette solution. Now for the third now, the final burette reading, again, it will be within that range of plus minus 0.1. So if you take 9.2 and you add plus 0.1, it will be 9.3. So it will be 9.3. And now for you to get the volume of solution, then now you subtract. So it will be 9.2. It will be 9.3. So that's now how to fill the burette version. Now the next question, calculate the average volume of solution A using. So if you want to get average, you add all the three values. That's going to be 9.1 plus 9.2 plus 9.3 divided by 3. So it will be 9.1. That's very good. Now, so the average volume becomes 9.2. Don't forget the unit, it is volume, so it will be 9.2 cubic centimeter. That's very good. The next question, we are told moles of sodium hydroxide. Moles of sodium hydroxide of solution L in 25 cubic centimeter. Remember now in sodium hydroxide, NaOH sodium hydroxide, you are given concentration in gram per liter, which was 20 gram per liter. So you are given 20 gram per liter. That's very good. Now from here, you are able to calculate molarity. So molarity is equal to concentration in gram per liter. Concentration in gram per liter divided by molar mass. What was the concentration in gram per liter? It was 20. So 20 divided by, what is the molar mass of sodium hydroxide? 40. So divide by 40. So the molar mass of sodium is 40. So get the calculation now. So that's now 20 divided by 40. So that now will give you 0.5 moles per liter. So if you have no molarity, then you are able to calculate more. You are able to calculate the number of moles in 25. So how do you do that? You say this 0.5 moles. Moles is in 1000 cubic centimeters, what about 25? So that one I will give you it. So that one I will give you the number of moles in 25. Moles always will be in 4 decimal place. So it will be. So that one I will give you 0.0125 moles. That's very good. Now next question. Calculate the number of moles of hydrogen reacted with hydroxide. Reacted with sodium hydroxide. You write the equation for the reaction, that is sodium hydroxide, NaOH aqueous plus the hydrochloric acid, HCl aqueous. The mole ratio is 1:1. So if the number of moles obtained was 0.0125, then that now equals to 1, ratio 1, becomes now under that. So the ratio now is 1, so the number of moles will remain same. So what about 1? So if you do the calculation now, the number of moles remains what, same. So the number of moles of hydrochloric acid reacted was 0.0125. Now the last question, molarity of HCl. Molarity of HCl. Molarity means the number of moles in 1000 cubic centimeters. This number of moles corresponds to the average volume. What about 1000? So we will say 0.0125. This number of moles is equivalent to the average volume, and the average volume was 9.2. It was 9.2. So molarity means what? Number of moles in 1000 cubic centimeters. So we say, what about 1000 cubic centimeters? How many moles are there? So if you do the calculation, now that will give you it. One point. That's very good. So now the molarity of the solution becomes 1.359 moles per liter. And that is the end of our lesson. For more, keep on following us. Thank you very much.